right, so I've had a request to go ahead and record the spring semester final review for Precal. And so I am going to do this in 3 parts. So each page, you have 3 pages for your spring final review, and we're going to do each page as a separate part. So here's part 1, and I'm going to expand this so you can see the problems a little bit easier. All right, so the first problem is about graphs, and you have to identify what kind of graph you have. So the question might ask, which one of the following graphs is the parent graph for tangent function? So you would have to pick A, B, C, or D, which one is the tangent function. So what I'm going to do is just review what all of these different graphs are with you so that you'd be able to answer that question correctly. Okay, A is a tangent graph, and we'll just call it tangent theta. The next graph down is B, and this graph here is a cosine graph because cosine graph starts at 1 on the y-axis, so this makes us a cosine graph. C is the sine graph. Sine graphs go through the center, so through the origin. So if your graph starts at the origin, that is a sine graph. And then, of course, D down here is not a trig function at all. This is a quadratic, so this one is just x squared. All right, so for question number 2, it's asking for the amplitude of the function. Amplitude is our leading coefficient of our function, and in this case, the leading coefficient is 2. For amplitude, we're not going to worry about negative signs because amplitude is not a negative value. So you would want to take the absolute value of that if your number in front of your function is negative. Otherwise, we're just going to use this number 2. If it's positive, you don't have to worry about it. If it's negative, you need to make that a positive number. So our amplitude in this case is 2. Okay, so in question 2, they're asking for the period of the function. So we're going to use our formula 2 pi divided by b. And in our function here, we have a is 2. We have that b is 1/3. We don't have a c for this one. And we have that d is 2 on the end. So we're going to use our formula 2 pi divided by b. In this case, b is 1/3. Well, now I have a number divided by a fraction. So in order to simplify this, we're going to have to multiply by the reciprocal. So we'll have 2 pi times 3. So our period is going to be 6 pi. Okay, so your fraction in your problem might not be 1/3, it might be 1/4, or it might be 1/2. So please pay attention to that. Your answer isn't necessarily going to be 6 pi. This is just an example. So make sure that when you're looking through your test that you are very careful about looking at all of your problems and making sure that you have the correct numbers. All right, for problem number 4, we're just solving for our angle. In this case, x is our angle. And so you will need your unit circle to find this angle. We're going to solve for x first. Actually, we're solving for cosine x, and then we're going to look at our unit circle for the angle. All right, so we have solved this problem. We added 3 to both sides of the equation. That gave us 4 cosine squared x equals 2. Then we divided both sides by 4. We get cosine squared x equals 1/2. Then we have to take the square root of both sides, and we get cosine x equals 1/√2. Then we have to rationalize the denominator. That means we have to multiply the numerator and the denominator by √2, and we get cosine x equals √2 over 2. Now we're using our unit circle to look to see where cosine is root 2 over 2. Well, that happens in 2 spots on our unit circle. One is at angle pi over 4, and the other one is at angle 3 pi over 4. So if what you're going to do on the test is you're going to select A, B, C, or D, whichever one gives you one of these 2 angles. Select pi over 4 before selecting 3 pi over 4, however. All right, in the next problem we are solving for the missing angle, and we've been given that this is a right triangle with sides of 8, hypotenuse of 13, and we don't know what the opposite side is. We could find out if we use the Pythagorean theorem, but we really don't need it to find the measure of this angle. We're just going to use the measurements that they've given us. Now, since side 8 is the side adjacent, and 13 is the hypotenuse, we have the ratio adjacent over hypotenuse, which is, as you know, the ratio for cosine of the angle. So we're going to use cosine of this angle to solve for the angle. All right, so we have that cosine is, or cosine of theta is 8 over 13. So to find theta, we need to do the inverse cosine, or arc cosine, and that's this right here. So in your calculator, you're actually going to go to your function button, and you're going to select the cosine inverse. Then right after you do that, inside the parentheses, you're going to put your ratio, which was 8 over 13. Now, if your calculator's in radian modes, you're going to get this. This is a radian, 0.9079. If you're already in degree mode, you might get this. This is your degree. If you don't get the degree, then you need to convert this radian into degrees by using the conversion 180 divided by pi. So you multiply your radian times 180 divided by pi, and that gives you the angle in degrees, which is approximately 52 degrees. All right, in the next problem, we are trying to find the length of a side. And in this case, our length of our side is x. And the problem is a triangle with angle measurement 22 degrees. And then we have the side down here, and we have this side. So we have 2 sides, and we have an angle. We don't know the hypotenuse. So when you have a side adjacent and a side opposite, and you don't know the hypotenuse, then you're going to use the tangent function, because tangent is opposite over adjacent. So opposite over adjacent, 5280. All right, so to solve for x, all we have to do is cross multiply. So we're going to multiply tangent of 22 degrees by 5,280. All right, so when I multiply 5,280 times tangent of 22 degrees, make sure when you put this in your calculator that when you put this 22 degrees in your calculator, that you put in the little degree symbol. If you don't do that, you're going to get the wrong answer. So 5,280 tangent 22 degree symbol, hit enter, you're going to get that x equals 2,133.26 feet. Make sure you're practicing this with your calculator before the test. Okay, for problem 7, here's another problem where we're solving for a side. Again, we're solving for this side right here because we want to know the height. So we know that the length of the ladder is 10.5 feet. We know that the angle that it makes is 56 degrees, but we don't know how high up the wall the ladder is touching. So we want to know how high up that is. So again, that's x. This time we have a hypotenuse, we have a side opposite, but we don't know the side adjacent. So since we have a side opposite and we have a hypotenuse, we're going to use the sine function this time. So sine of 56 degrees equals opposite over hypotenuse. And we're going to solve this one just like we solved the one prior. So we're just going to cross multiply here. We have 10.5 times the sine of 56 degrees. Make sure that you're putting your degree symbol after your 56. And then when you hit equals, you'll get that x equals 8.7 feet. Which makes sense when you think about it. And you're looking at the other length in the triangle. 10.5 is the longest side, and it should be longer than this side that's opposite, and the side that is opposite is 8.7. So that makes sense. Okay, so we're going to use a unit circle to find the exact value in radians. We want to look where sine is -1/2. So look around your unit circle and find all the places where your y value in your coordinates is -1/2. That's going to be your sine inverse value. All right, so our sine inverse value where sine is -1/2 is going to be located at 7 pi over 6 and at 11 pi over 6. Those are the two angles where this occurs. So on your answer sheet, you'll see A, B, C, D. And best to pick this one right here. 7 pi over 6, that's on the right side of our coordinate plane. So let's go ahead and pick that one as the choice we want for this particular angle. All right, so the next one is super easy. This is just a cosine inverse or arcsine times a cosine. And so what happens here is these cosines just cancel each other out, and we're just left with this angle right here, which is pi over 3. And that's the solution to that one. Okay, so for problem 10, we have find the exact value of the following, no decimals. All right, so the way we're going to do this is we're going to find the cosine of this triangle here that's formed by the cotangent inverse of 4 over 3. Well, we know that cotangent is adjacent over opposite. So cotangent of theta is going to be adjacent over opposite. So if adjacent is 4 and opposite is 3, then I can draw a triangle that represents theta where my side adjacent is 4 and my side opposite is 3. Then I can use that information to find my hypotenuse, and in this case we have a Pythagorean triple, and I would imagine that on your test you're also going to have a Pythagorean triple. So you may have to use the Pythagorean theorem to find it, but if you already know your Pythagorean triples, then it won't be too hard to find. All right, so then what we need is we need the cosine of this triangle that we've created. So the cosine is going to be side adjacent over hypotenuse. So here's my side adjacent, here's my hypotenuse. So the cosine is going to be 4 over 5. And that's the answer to that one. All right, problem number 11, all we have to do is simplify. When we're simplifying trigonometric functions, we want to change all of our tangents, cosecant, secant, whatever we have, into sine and cosine and simplify. So I'm going to change this tangent into sine over cosine, and I'm going to change the cosecant into 1 over sine. And then I simplify that, and I end up with 1 over cosine x, which I know according to my formula chart is just secant. And then I'm done. Okay, so in the next problem we have the Heron's formula. That's S equals A plus B plus C divided by 2, where A, B, and C are the sides of the triangle. And then we put it into the square root formula. And it's right here and should also be on your formula chart. Okay, so you just plug the numbers in. 12 plus 8 plus 6 divided by 2 is 13. Your numbers on your test are going to be different, so make sure that you do your own calculation. All right, you put that into the square root part of the formula, and we get 21.33 meters squared. So make sure you practice this on your calculator before the test so that you are confident that you are entering it correctly. And that's it for part 1 of the review. Part 2 will be in a separate video. Okay, so here we go. Can't seem to make it through a video without some mistakes. So on number 4, I gave you the wrong angles. Cosine of x is root 2 over 2. And the angles that correspond with that value for cosine is pi over 4 and 7 pi over 4. Okay, not 3 pi over 4. So it's pi over 4 and 7 pi over 4, quadrant 4. All right, so the best choice here is going to be, for cosine, is going to be the pi over 4 choice, since that's in quadrant 1, and since quadrant 4 is where 7 pi over 4 is located, probably best to choose the first angle. All right, for the next one, problem 8, where sine is negative 1/2. Again, I was looking at it backwards or something, but anyway, let's get these angles correct here. Okay, sine is 1/2 at 7 pi over 6 and at 11 pi over 6. And since 11 pi over 6 is the angle that's in the right side of your Cartesian plane, let's go ahead and choose this one as the better of the two choices for our sine angle. All right, so hopefully that fixed the problem we had here. And if you have any questions, please, ask me. Come stop by the room, ask me if you have any questions before you take your final, seniors especially. Make sure you've got it all down. Sorry for these mistakes. Just make corrections on your review sheet. Make sure you're looking at your unit circle. You know that the x value of the coordinates is the cosine value, and the y value is the sine value. And that's all I have for you right now. Go ahead and make sure you understand how to work these problems before you move on to the next section.